All right, let's go ahead and get started. Everybody. Hi, everybody. How are you all doing today? All right. Last time we talked about a bunch of stuff. We talked about output formatting. Do you remember that? Cout displays this many digits by default. The answer is? We talked about alternate assignment operators, things like plus equals. What does this do? It adds whatever is on the equal sign to whatever is the variable is on the left and stores it all in one step. So this is equivalent to something equals something plus 1 or plus whatever. Mod equals, what does this do? Same thing with mod, it'll change that. Okay, we talked about the increment operator. Plus plus x, what does this do? All right, if we were to output this, would it output x or would it output x plus 1? How about this one? It would output x, but after the output, it would increment 1. So something I forgot to mention that's very complicated. I hope I can do it justice in this amount of time. There's also a decrement operator that works in exactly the same way. It's minus, minus, and minus, minus. Got it? Okay. We talked about strings a little bit. We'll talk about those more today. One of the things that you need to do is make sure you have pound include string at the top, because otherwise it may not work on the CS class compiler, and then you would be in trouble come grading time. We played a couple of games of The Code is Right. Was that fun? Good. I got to Costco and I bought a whole bunch more candy. So we've got that. But today is going to be no fun whatsoever. We're not going to play The Code is Right. We'll have a little break or something like that. But we have a problem. And here's our problem, other than that we're not going to have any fun, is that on Thursday they are predicting a large snowstorm. Yes, really, they are predicting a large snowstorm. They're predicting the mid-range is 6 to 8 inches of snow. The low range is it's going to rain and we won't get any snow, but they're thinking at least an inch. And the high range, which is a small chance, 10% or less as of right now, is 20 inches of snow. Okay? So this is a problem for us. Seriously, it's a big problem. We already had a snow day in this class. In this class, there's so much material that we can't have a snow day. We cannot have one, and there's just no way we can have two. So we're so far behind, we have a lot to cover. And you probably looked at your algorithm and have no idea how to do your algorithm because we're a day behind, and I haven't told you stuff, so we have to get the stuff today, and we have to make sure we have stuff in case there's a snow day on Thursday. And if there's a snow day on Thursday, we'll do one of two things. We'll either push all the deadlines back or we'll just quit and we'll just cancel the course because we've gotten too far behind. Okay, and so we'll talk about what to do in that case. All right, so everybody ready? Let's go. Any questions before we begin? Seriously, we can answer some questions. I'm going to talk about what we need for the project, yeah. Was that your question? A what? There will be. Eventually when the other instructor gets around to doing it. So, yeah. It's funny, you know, the thing I've learned from this class is the more stuff we give you, the more you want. I never used to give rubrics, I never used to give stuff, and now I've gotten weak in my old age or something. So, I'm nice to you all, and then you're always like, be nicer. So, all right, so the answer is eventually there will be a rubric, and I have no idea when, so. All right, let's go ahead and get started. So last time we were talking about strings. Everybody remember what a string was? What is a string? Yep, let me just set up some code here for us to work with, which I should have done before. All right, so what we had talked about is we had gone through the fact that CN, when you give it input, breaks up the pieces of input based on what? Spaces. Now when we say spaces, it's not just the space bar. It's any white space. It's tabs, it's returns, anything like that. CN breaks on space, where space is a space or a tab or return. And so we talked about the other thing that we could do for input, which was called getLine. And what does getLine do? GetLine gets from wherever you're currently doing input to the very end of the line. So let me just run this again so we remember where we were and what we were doing. I'm just gonna get everything organized here. All right, so we'll compile this really fast. Hello? Oh, you're kidding me. Okay, now I can switch back and forth. I have the wrong version of the code. I accidentally closed my editor. All right, so we'll compile this someday. Yay, and we'll run it. And we can put anything we want in here with divided spaces, and it's going to accept that as input, okay? And so what I did is I just typed a whole bunch of stuff, and it was able to read the entire thing without any problem. Now here's what I would like to show you, is that you can combine using CN with getLine, okay? You can combine CN with getLine. And here's what will happen. If we do a couple of other things, let's just put another variable in here. And we'll just call it garbage. And what we'll do is we'll say, okay, the first thing we're going to do is we're going to CN into garbage. And then we are going to getLine. Here's what's going to happen is CN is going to take the line of input and take everything up to the first space and take that and put it in the variable named garbage. And then it's going to take everything else on the line and put it in the name string. So here's what we're going to do is I'm going to change my output so we can see which is which. And I will also put one here so we can see what the garbage was. So we'll clear, we'll go back and compile. We will run it. And now when I run, I can put a whole bunch of something. This is the garbage, and then a name. And you can see that garbage, the first thing, read that whole thing up to the space, right? Everything up to the space. And then beyond that, it took everything up to the end of the line, all right? So you can combine, the message here is that you can combine CN with getLine. And you can do multiple things. I mean, if we wanted, we could have, CN read the first few fields and then getLine read everything till the end. Yes, sir? Absolutely. And if we wanted, we could do another thing here. We could put, CN into garbage again. Well, let me make another variable so we can differentiate between the two. All right, so I changed the code a little bit, and we'll go back and look at it just 1 second. And when we run it, here's what we see. If we run it instead of compile it, here's what we see. We put some garbage. Now when I hit enter, it's going to hang, right? What is it hanging for? It's waiting for the other garbage. Okay, so what happened is if I go back and I show you the code here, we had 3 variables, one named name, 2 things named garbage and garbage2. We say enter name. We did CN into garbage, which takes the first chunk of space, the first chunk of characters up to the first space. Then it does getLine with everything that's on the rest of the line, and then CN after that will get whatever is on the next line up to the space. All right, everybody good with that? So you can combine these two. And often in the projects for this class, like when I give you files to read, I give you a format where you have to combine these two. This one I don't think I did, but we probably will for project 3 and beyond. Have to combine using CN and getLine together. Okay, everybody good on that? All right, so that's string input, and string input is, of course, super useful because we have to be able to do that. All right, questions so far? Yes? So if we run this, like if we run, this is just a quick example because I'm like trying to get through this quickly. So if we run this and I put some garbage and then a name, it just hangs right now because it said, oh, well, you did the first CN, which is this stuff, the KDJ bunch of stuff. You gave me a name, which is Clay, and so I read to the end of the line. And now there's another line that says CN into garbage 2. It's waiting for the other garbage now. Now, obviously, you know, we don't just fill our files full of garbage. Garbage is just an example. One way you might use this is if you have like a title, like Dr. or Mr. or Mrs. You might use CN to read the title. And then after the title, you know that there's a name that has a bunch of stuff, a bunch of words, but you don't know how many, so you might use getLine from there. So a better example would have been title instead of garbage. Sir? No. So what'll happen is it'll ignore a whole bunch of spaces together. So let me demonstrate this. Here's some garbage. Here's Clay. And then the question is, what happens if you have some spaces first? Remember, CN is going to do its best to help you out. And CN will look and go, okay, there's some spaces. I'm just going to throw those out until I get something that actually makes sense. If you want to read spaces, you have to use getLine. You have to. CN will not read spaces for you for string. All right. Questions on this? So I want to show you a few other things about strings, okay? And what we'll do is we will write this out to a new file called string4, and we'll kind of start over again. So let's say that we want to input someone's name and output it. This is what we had before. Let me ask you a question. A string is a whole bunch of what? Characters. Do you think, well, this is a bad question because you're all going to answer yes anyway, that there's a way we can get individual characters and pluck them back out of the string? How many of y'all think that? How many of y'all think once it's in a string it's impossible? Yeah, well, that was like the lamest rhetorical question I've ever asked. So let me just go ahead and show you how to get characters out of the string. Once you have this string, you can use what's called a method on it. And the idea of this using a method is you use the variable name that you want to call the method on, and then you put what it is afterwards. So we saw functions before, right? Remember functions? We saw functions for math where we used the floor and ceiling, and we talked about arc, cosine, tangent, and stuff like that. Those are functions. They stand alone. A method is kind of a function that works with a thing. So name.at will give us the character at a particular position. So name.at1 should give us what if I enter my name, Clay? It should give us a C, right? Does that make sense? So Clay, my name, 4 letters, C-L-A-Y. What's the first letter? And so if we ask for name at 1, it should give us? Okay. What? Heretic. All right, let's see what happens here. So let me clear the screen. We'll compile this new program. All right, it compiled cleanly. We're happy. We will go ahead and run it. It would help if I had some output, what we were asking for, right? Okay, we'll compile it again. We'll run it again. It says enter your name. I put an end line there. I probably shouldn't have. Clay, C-L-A-Y. And we expect it to print out capital C, and instead it prints out L. We just couldn't see it very well. Let me clean up my format a little bit here. All right, here is one of the things about computer science. Enter your name, Clay. The first letter was L. How many of y'all think that's absurd? How many of y'all think you know how to fix this? How can we get C instead of L? Yes, someone shout it out. He said 0, just because he was closer, I heard him. When you're working with strings and you're working with @, we number all the letters there from 0 to n minus 1. So if they have 4 letters in there, they are numbered 0, 1, 2, 3. Okay? There is a historical reason for doing this in computer science. There is a historical reason, and here is the reason. I'm not going to tell you. I'll tell you some other time, okay? It may not even come out. It'll come out later in the semester, but there's a reason we start doing things at 0. I just don't need to explain it yet. But can you all trust me on this? So what do we put in there if we want it to print out y? 3. And so now if we compile it and run it, we should see that if we run it now, we get y. Does that make sense? All right, so you can use the at method, and we know it's a method because it follows a variable. We say dot, we have this dot after variable name, we say at 3, and it says look in the string and give me the thing in position 3, but the positions are numbered starting at 0. 0, 1, 2, 3. Okay, does that make sense? And there's a reason for it that I'm not going to explain. Everybody happy with that? Questions? Yes? Mm-hmm. Mm-hmm. So no, so I took away the code that did the garbage stuff. If we had a different variable that was doing garbage and it was sucking all the garbage into that and then using getLine for clay, it would still work on the name variable. Because what it does is it just says for this particular variable that contains a string, go look in there, and there's a memory box, actually series of boxes that has these letters, and tell me what they are. Right? And then tell me what the one in the third position is. So it goes, okay, 0, 1, 2, 3, 1. So whatever variable you apply the at method to, it will do it. So the answer to your question is, as long as we have read the name correctly, if we read garbage first and there's something stored in name, it will always work on name. Okay? Does that help? Sir?
Does it always just take from like whatever's the previous input when you use the name?
So, okay, so let me explain, because I'm trying to go fast, and what ends up happening in this class is when I go fast, I confuse you, and then I have to go slow down. So obviously I'm going too fast. So let's step through this algorithm and see. Where do we start when we run a program? Int main. What does string name do? It creates a variable named name, which is of type string. Cout says enter your name. GetLine says whatever the person types, including spaces, take all those and store them inside name. With me so far? Now we output name, which was what was stored in there. Now we say, okay, cout, the first letter was, and now it's completely a lie because we put this 3 in there, right? Name.at3. So it says, okay, I have this variable named name. I want to go in there, and I want to look in the third position, and I know it's the third position starting numbering at 0. Okay, and it outputs that. So if we really want to output the first letter, it should be 0. Okay, who's with me? Okay. Who has questions? Yes, sir. No, and if I can prove this to you. What'll happen? GetLine might. Yeah, Getline should get spaces, right? Right. So Getline gets the spaces. CN does not get spaces. So you can see I kind of highlighted it in blue. I don't know if it shows up on the projector, but you can see those spaces there, and it says the first letter was space because Getline gets all of that stuff together. Getline gets spaces, CN does not. Everybody good so far? Yes, sir. People range from imperfect to suck. So no, you cannot assume that the user will not just randomly input 6 spaces before that. Sadly, like I said, dealing with people is the hardest part of this. If all we had to do with was computers, it would be easier. So, and less useful. All right, other questions? All right, let me show you something else. So we can use this to get a particular letter. We can also use a method to find out how many letters are in the string. And just like we had the at method, we have the length method. Okay? And the idea of this length method is it will tell us how long the string is. So if we go back over here, oh, yep, there's no number in there. Okay, so if we go back over here, clear the screen, compile, we run it, and we say enter your name as Clay, and it'll say the first letter is C, and I am in copy and paste hell because I copy and pasted without changing all the stuff I should have. Now it should work. Okay, we enter our name, Clay. The first letter is C, and the length was 4. Okay. All right, so here's what we did. Before we used the .at method, which required a number in there, and this number is referred to as the argument that tells us which letter we're interested in. And we also have the length. Now, what does the length return? What does the length tell us? How many characters in there? How many characters are there? And they were numbered 0 through 3. So length tells you how many things are in there. .at lets you get at them, but they are numbered starting at 0. I'm going over this because there'll be an exam question on this, and some of you will miss it. Okay. All right, so we got length. We've got at. The other thing that we can do sometimes, by the way, any questions on length and at, by the way? Yes? If the user puts a bunch of spaces in front, the spaces will be included in there if you use getLine. Now, I know what you're asking me is like, how do we fix that? And the question is, I'm trying to show you these general things so that when the time comes, you can think about which to use. I have no hard and fast rule for you about what to do when the user enters 6 spaces in front of their name. And the reason for that is because I don't know, like that was a hypothetical question. I don't know what the hypothetical program we're trying to write is. It could be that sometimes we want those 6 spaces because for some reason we need them. I can't imagine a reason we do, but it could be in some cases we want to get rid of those. Okay, does that make sense? And so do you have to account for the fact in the general case, if you're writing a program, that somebody might put some spaces in front of their name? Yes. Do we have to deal with that in this class on a project or in an exam? No, unless I tell you otherwise, okay? Yes? Absolutely. Sure. So if we want, we can do something like int name size equals name.length. It's an integer. And we just put this down here instead because it's just an int. And we've seen ints before, and this program should do exactly the same thing as it did before. We compile it, compiles cleanly, we run it, enter my name, Clay, and it still says the length was 4. It's just this time, instead of only printing out, only evaluating this name length and printing it out, we actually stored it. We created another variable and stored it in memory. Okay? Make sense? Everybody good so far? Yes? I am initializing it by giving it a value immediately. Does that make sense? So I don't have to do it in 2 steps. I don't have to say it's equal to 0 and then change it. I can do it in 1 step. And notice also that I didn't declare this up at the top, right? I just declared an int where I needed it. You can also do that. I would encourage you to declare your variables at the top in general. I'm being sloppy today because there's a lot to go through, and I probably shouldn't because, like I said, when I go too fast, you make me slow down. So slow is actually fast. All right. Everybody good so far? All right, stand up. 1 minute break. Go. Who needs almond joy bar? Anyone else? Oh, sorry, Nestle. What? It's like mostly Almond Joys. Why would you get? Milky Way. I've got Snickers. Sorry, only a Rolo there. Not trying to shortchange you. No, I'm not. I have like a 20-pound bag of this in my office. It's like almost free at Costco. So, okay, and then I don't eat it if I give it to you. So, all right, welcome back. So we're talking about strings. We've talked about a couple of things: the at method, the length method. There's a few other methods that work on strings. Let's do something else. Here's what we're going to do: is we're going to say string title. We're going to ask people for their title. Cout. Enter your title. Cin into title. And what we'd like to do is we would like to combine the title with the name. Yes? Yes, I do. Okay. So now what we're doing is we have our algorithms ask someone their name, figure out what the first letter is, figure out how long it is. Now ask them for their title and enter that. Okay? And when we're done here, we'll see out the title and the name. All right? Make sense? We'll compile this. We will run this. My name is Clay. Title. Jeez, I don't know. Mr. So it says Mr. Clay. And it output it. But the Mr. and the Clay are actually separate. Right? They are separate variables. We may want to combine them somehow into a single thing. So what we might want to do after this is come up with something we call like full name. And what we'd like to do with this full name variable is combine the title and the name we were given. I'll try and move the text up so you can see it back a little bit. So here we entered the output, created the variable to hold the title, asked for the title, input into it, cout the title with the space in the name, but what we'd like to do is put them together. We'd like to join them together. So here's what we're going to do. We're going to create a full name string, and what we're going to do is we're going to do full name and a method called .append. Anybody want to guess what .append does? It appends. It adds to the end. And we'll say append title, and then we'll say full name .append a space, and then we'll say full name .append the name. And what do you think this is going to print out now? Do I have to what? Do I have to capitalize what? Thank you. Okay. So what we're going to do is we're going to take this string full name, and what's in this when we start it, when we create it? Nothing. Nothing's in here. For the basic types, int, bool stuff, we don't know, but string, because it's magic, it has its own magic, makes it empty when it's created, which is the nice thing about strings. Okay, we say .append, we take this empty string and we append the title to the empty string, and what's in there now? Just the title. We append a space, which means title is followed by space. We append the name, so we should have title space name. And now I'm going to get rid of this other cout up here, and we're just going to output full name. Now we should output exactly the same thing. So we'll compile it. It works. We will run it. My name is Clay. Professor. And now it's Professor Clay. Right. Everybody with me on this? So append works by adding things to the end of the string the method is called on. So we had the string full name. It was empty. We called append title, and it took the empty string and added the title to the end. Right? Then we added a space after that, and then we added name after that. Who's with me? Makes sense? Who has questions? All right, one more thing we'll take a look at two more things really fast. The first is that instead of append, we can use what's called the plus operator. So the plus sign works on strings in the same way that append does. Hang on a sec. And let me just make a new version of the program so that you can see this one in the, if you need to go back. Okay, so what we're going to do here is we can replace all the appends with a plus sign. And it will work exactly the same way, because in C++, this plus sign works like append works. Oh. What? Oh, plus equals. Sorry about that. Let's see if that should work. So, sorry, I forgot the equal sign the first go around. All right, so before we used append, but it turns out that string is built in such a way that we can also use plus and plus equals to append things to it. All right, one other thing I will show you. Actually, I'm going to show you two things. I'm going to show you one thing. I would like to show you two, but we don't have time. Do you have a question? No. Okay. And it's this. We know that C++ is a language that is descended from another language, which is called, C++ is C. C is equivalent to Latin, and C++ is your choice of Romance languages, like French or something like this. So there are times, occasionally, in working with C++ where we run into weirdities, oddities, like the irregular verbs of computer science. And I'm about to show you something that is useful in one of these situations. It is possible in C++, let me rephrase this. In C++, strings are different than they are in C. Okay? Strings are different than they are in C. However, some of the things that we use strings for in C++ expect not the C++ type of string, but the C type of string. Does that make sense? So, in C++, strings are different than they are in C. Occasionally, we need to use things that are a C string. And here's how we do that. C_str, open close parentheses. And what this will do, this method takes your C++ style string and turns it into a C style string. Now, you may be asking yourself, why the hell would you ever want to do that? Somebody want to ask me that? We'll get to that shortly. Okay. I'll show you. It's absolutely necessary that we're able to do this because of some of these irregular things that happen since we're descended from the C language. Now, when I run this program that has this C string, everything is going to look exactly the same to you. Exactly the same, except I can't type. And it's still outputting things, but this prof clay that's getting output is C-style string instead of C++. It makes no difference to how it's displayed. It makes a difference as to how the compiler considers it a type, right? Because we have like int, bool, float, string as a type, but a C string is a different type that I'm not going to go into, but it is a different type that we need sometimes. All right. Okay. Do you all just believe me? Are you willing to take that on faith right now for the moment? Okay. Good. All right, so let's move on to something a little bit different. And it's something that we need for the project, and it's something that we should get to. How many of you all like typing? How many of you all really would enjoy a job doing nothing but data entry where you get like giant cards that people have filled out and you sit there and all day and type stuff? Nobody? Nobody's looking forward to an exciting, fast-paced career in data entry? All right, typing sucks. How many of y'all agree that? Yeah, and you'd rather not do it. So how many of y'all like programs that every single time you run the program, you have to type everything into the program? How many of y'all would rather be given a file that has a bunch of information, and then when you run the program just says, hey, what file do you want me to take all the information out of? So you don't have to type. Is that way better? So what we're going to do is we're going to start working on that, and this is part of what's going to be in the next project. Okay? So let's create, we'll call it file io.cc, pound include IO stream. And if we're going to use input from files, we have to include a different thing, pound include fstream. Now, we know that these includes that are up at the top are libraries that other programmers have built for us so that we don't have to do everything manually. The fstream is essentially what's called the file stream. And this allows us to do file input and output. Okay, everybody with me so far? What are we trying to do here? File input and output, and this library is for us to do that. So, int main, return 0. What does this program do right now? Yep, it does nothing. Okay, so when we're working with files, just like we have variables for int, just like we have variables for string, we have to have a variable that represents, it doesn't hold the entire file, but it represents the file. And for input, the way we do this is ifstream. And this stands for an input file stream. This is the place we're getting data from, and we can call it input file. Or you can call it any other thing you want, right? It's a variable name. You can call it whatever is relevant to your needs. I'm calling it input file here. Now, when you create this variable, you have created something that represents a file to get data out of. Does the program know what file you are referring to yet? No. How many files are on your computer? Are there more than one? Yeah, there are probably a few million on your computer, right? So we have to tell it which one we want. The way we do this and the way we create this connection between this variable that's going to represent data and the particular file is by using a method. And using the method on this is called the open method. Input file.open. Now what goes inside here in between these quotes is the name of the file you would like to open. Okay? So what I'm going to do right now is I'm just going to take a quick break and I'm going to create a data file. And we're going to put some data in here. It's going to be a text file. And how about, what do you want in there? Some integers, strings, floats, any strong feelings? All right, let's put some animals in there. Cat, dog, rat, and moose. So I just created an input file. And what am I doing here? Oops, I'm in the wrong program. Okay, so I just created an input file, and it's called data file. .text. Now, for our purposes right now, what I'm doing in this example program to show you how it works is our program will ever only work on this single file named datafile.text. And we know that datafile.text that I just created has a bunch of what in it? Animals that are represented by strings. So they're animal names are strings, so we're going to be reading some strings in from the file. Okay? So here's what happens. You create the file, create a variable to hold file, a variable to represent the file. This connects our variable to the file. Now here's my question. Is this connection always going to work 100% of the time? How many of y'all say, yes, everything always works beautifully on computers? How many of you say, no, things can always go wrong, and in fact, going wrong is generally the default situation? So we need a way to check and make sure that when we opened our file, everything went according to plan. Things that can go wrong in opening a file, you might have the wrong name. The file might not exist. You might be on an operating system that you don't have permission to read a particular file. There's a lot of stuff that can go wrong. So what we can do is we can check to see if the file opened correctly. And we do most of our checks with an if statement. To check if a file opened correctly or not, we can just use this. If not, input file. Now I'm going to tell you a little bit what's going on behind the scenes here. We know that in a Boolean variable, 0 is, and true is anything that's not. So what happens is if this file doesn't open correctly, input file has a value of 0. Okay? If it doesn't work correctly, it has a value 0. So if we say not 0 is true. So this is the check. So if the file didn't open, we can output a message. And typically we want it to be very complete, like file not found. And then everybody will know exactly how to fix it. And we can return. Now, one of the things about return is so far we've been doing return 0 all along. Most of the time in C++, return 0 means that everything has gone well and we are leaving happily. Sometimes when things go wrong, we would like to pass an error code back, and so we return something that's non-zero. Now, I'm just going to put -1 in there because that's like a common error message. Return -1 means something went wrong. On big programs, different codes will return different things, and it's all part of the process. Anybody ever been running their program and it like threw up a little box that said program to end error and it had some number there? No? Well, you see it sometimes. It's just a common way of when things go wrong for debugging purposes. So I'm going to put a return -1 there because that indicates we had an error instead of something happy. All right. Now, if we get past this if statement, that means that our file opened correctly and we are happy. Yes, sir? This if not input file? Yeah. It's a little bit of magic. And the magic is that if input file open works, if this works, then the value that input file has as a variable is not 0. If it does not work, input file is 0. So what we're saying is if this doesn't work, input file is 0. And if we're saying if it is, if input file worked, it's a number, right? And we know that anything that's not 0 is, and not true is. So this just checks and makes sure that the file opened correctly. Because if input file is 0, it did not open correctly. If it is not 0, it did. And if it's saying not open correctly. There are other ways to do it. This is the shortest, most terse notation. All right, everybody happy with this? You can just assume it's magic if you want and type it in to check that the file opened. All right, so if we make it past here, we know the file opened because if the file did not open, we would return and we would have stopped the program already. Right? All right, so now the question is, now we have the file open, how do we read from this file? Oops. And the answer is pretty easy. Once we have the file open, everything works almost exactly like cin. So if we create some sort of variable, like animal, animal, there we go. We can just do something like this, input file into animal. Everybody's looking confused, so obviously I did something wrong. Input, okay, thank you. So just as a totally random aside, there is a a programming paradigm where people like work together on big projects. It's called extreme programming. And do you know what extreme programming is? Anybody ever heard of it? Probably not. Does it involve like snowboards and a whole bunch of Mountain Dew? Actually, it involves two people working together on the same computer, so that instead of everybody having their own computer and programming, you have two people who sit together and work together and program together just to catch stupid mistakes like this. And so it's a way of keeping bugs from going into your program. All I can say is you better like the person you work with. Otherwise, that would be a very long and frustrating job. Okay, so if we get here, the file opened, and we'll read something, and we'll say input file animal. And let's just see what we got out here. So here's our program. Here's what we're going to do. We're essentially create a variable that can hold a file. That is the ifstream input file. We connect this variable to the file by using the open call. We check that the connection worked correctly. If it did not work correctly, we output a message and exit with an error code. If we get past here, we know the file opened, so we create a variable to store something in. And then using input file angle, just like CN works, we read the first animal out of the file into the variable. Sir? Return -1, so we've been returning 0. 0 means everything went fine. -1 means something went wrong. Yeah, it stops. It's just like I can stop. When the program stops, you can tell the operating system everything went fine or something went wrong. That's all it does. And in fact, I normally don't tell people that. I just like you all, so I thought I would give you that extra bit of knowledge. You're welcome. All right. So let me just check. I'll show you our data file again just to make sure there. And so we have a cat, a dog, a rat, and a moose in our data file. So here's the file that we're going to read. So what is this program going to output? Okay, we're only reading one variable in, the very first one, so it should only output cat. It should only output cat. Let's actually see if we got this right or not, because normally I try and compile more as I go along. I'm pretty confident, though, that you're all catching my mistakes. All right, so it worked. Let's run it and see what we get. It says animal was cat. Okay, so it was able to open the file. It was able to read the line out of there, and it was able to output it. And are we happy? How many of y'all are happy? How many are unhappy? How many of you are just devoid of emotion right now? All right. So questions so far. I'll go back to the code and you can ask me questions. Yes? All right. So if you want to pick, here's what happens. For input, you have to explicitly read every single line. So here's what I did is I cut and pasted those same lines over and over and over again 4 times. And so what the first one says is it says read something out of the file and put it in animal. And the first thing that it can get that doesn't have spaces is cat. And then it breaks on the return and then it outputs cat. The next one says, okay, what do we read from there? And it goes, well, I just finished reading cat. I'm scared of your question, but just one sec. And so it goes, oh, I have to read something else. The next thing I can get up to a space, that's a tab or a return, is dog. The next thing is rat. The next thing is moose. So each one of these lines will read one line and output it. Yeah, so what happens is we only have one variable. The first time we read cat and we put it in there, right? The second time when we read it, we take whatever's next, which I believe was dog, and it overwrites cat. Cat is gone. We have one box and only one box. The first time the box said cat, the next time we say, hey, you have this box with the cat, put the dog in there and the cat is gone. Next time is rat, next time is moose. It overwrites it each time. Sir? Yes, if you want to do some calculations related to that, we're going to fix this. We're going to make this a little bit better in a minute. But I just wanted to kind of demonstrate what was going on here. Sir? It breaks on any space, but the end of line is a space. So CN will break on a space, on a tab, on a return. and a whole bunch of other things that I don't want to get into. But that's most of what you'll see. Yes, sir. We can use getLine, and we use getLine just. Do you want to use getLine for one of these? Well, let me prove that this works first, and then we'll use getLine. Okay. So we'll compile, we'll clear, we'll run it, and now we can see that each time it read something, it read the next line. Everybody good with that? How many of y'all are good? I'm going a little fast, I know. I just really want to get through this so that you have what you need to do to work on. Now the question is, can we use getLine? And the answer is yes. Let's change our something else to, let's change one of our things to the Norway rat. Okay? Norway rat is famous, of course, as a spreader of, yeah, disease, right? No friend of mine, thank you. Now, if we have Norway rat in there and we just run this like it is, you can see that one animal is Norway and one animal is rat. Are we happy about that? We're not. So one of the things we could do is we could change our input file into a getLine. And I'm only going to change one. It doesn't really matter because I happen to know this line has two things. Right? And getLine will get, for that particular line, everything on the line. And I just did it on that one because I know that's where we're going to see Norway rat. Okay. All right, here's what we're going to do. There's something weird happening that I don't want to explain right now because it's just weird and dumb and confusing. And so let's just change our data file and we'll make the Norway rat the last guy. And that should help us. I hope. Anyway, you can use getLine. So what's happening is there's not a space. There's like an invisible end of line marker that's getting caught in there that we have to clear out. And it only happens sometimes, and it gets annoying to deal with. So if we ever have to learn how to deal with this, I'll teach you, but I don't want to go into it now. Anyway, I'm sorry that didn't work perfectly. That's what I get for doing things on the fly and answering questions. Everybody okay with them not working for the time being? All right. How y'all doing? Is it time to stand up for a sec? I can't remember how long it's been. Do y'all need to stand up? All right, 1 minute break, stand up, stretch. All right, that was about a minute. How y'all doing now? Better? So let's say we're going to be reading a file, and it's an input file, and it has a bunch of stuff in it. How many lines of input does your input file have? How many does this one have? How do we know that? Because we wrote it, right? And we know exactly what it is. But in general, are all files that are data files going to have 4 lines in them? How many are they going to have? They can range, what's the smallest number of lines they can have? And what's the biggest number of lines they can have? Pardon? Infinity is probably a little bit too big, but they can be pretty big, right? Like the biggest file that I probably have on my computer is on the order of like, I don't know, a few hundred gigabytes, right? Like HD video thing can be pretty big. Terabyte. So these things can be pretty big. So what we need is not some way to just read every single thing one at a time. What we need is a way to read an indeterminate number of lines. that make sense? So, do you remember, and it seems like years ago now, the first couple of days of class where we did flowcharts? Is there something we talked about in flowcharting that might help us here? Sir? A loop. And here's what it's going to look like. We are essentially going to have a loop that looks like this. We're going to ask, are we all done reading the data? And if the answer is yes, we'll go off and do something. But if the answer is no, we will read the data, go do something with it, and then go back and check again. Okay? So, just like we have an if statement that has a Boolean condition, and we only do the thing in the if statement if it's true, we are going to have a loop. And the idea of the loop is going to be, if there is still data to read, go ahead and read the data and go back and do it over again. So the way this works in C++, we'll go into this more detail a little bit later, but I wanted to get to it today for what by now is hopefully an obvious reason, is what's called the while loop. And a while loop looks like this. So this looks almost exactly like an if statement, right? Remember we had if and then a Boolean condition and then parentheses. A while loop looks exactly the same. The difference between an if statement is you only do things once, and a while loop does things as long as the while loop is true. Okay? As long as the condition in the while loop is true. And I'm going to get you some more examples of while loops later, but I would like to give you the explicit one that works for reading files, which is where we would be today if we were not a class behind. Okay? So, the easiest way to do things is this. This is the easiest way to read a file for us. You say while input file into animal. And what's happening is every time it tries to read from the file into animal, if it reads something successfully from the file and puts it in animal, then this animal will have some value that's non-zero, and we know non-zero is true. And so if it's true, it does what's in the loop. If for some reason input file goes to read something from the file and it is not able to, do you know what it does? It returns 0. Just like we had up here, it essentially returns 0 and goes, oh, I tried to read something and I could not, so here's a 0 for you. And what happens if you have a 0? It's false, it doesn't do it. So, let me demonstrate. We'll just do cout what was an animal here. And instead of having 4 lines and 4 input and output statements, we only have one input right here. We have a line that does input, and we have a line that does output. And what will happen is as long as we're successfully reading input in, it'll output into the output. So anybody else have some favorite one-word animals they like? Frogs, iguana? Nope, baby toad has 2 words. Nematode. Is that right? Dragon, unicorn, lion, shrimp. I like that one. I would eat almost all of these things. Bear. Okay, except maybe a nematode. I'm going to be kind of iffy on the iguana. Okay, so here's what we're going to do. We're going to compile, and we'll see. We'll see. Dragon rolls, sushi dragon rolls. That counts, doesn't it? All right. So we just changed our data file so that we have a lot of stuff in here. How many lines was that? Anybody count? I don't know how many lines it was either. It doesn't matter because the computer is just going to keep blindly going on until it stops. And so now we'll run it and see what happens. And it was able to output every single animal in that file at once, okay, which is awesome. Right? Okay. Everybody happy so far? Everybody kind of makes sense what's going on here? So a while loop, it's exactly like an if statement, but an if statement only does things once, and a while loop keeps doing the thing in there over and over and over until the Boolean condition in here is false. Okay. All right, everybody good with that? I am so relieved this is exactly what I wanted to get to today, and we have 15 minutes left, and I'm sorry if I went really fast. But this is what you need for your project. Now let's show you one other thing, okay? Let's say that instead of, just having one word here, we had a blue cat and a red dog. I don't know, what kind of moose? What are they? They're kind of dingy colored. Rats are gray. Scaly snake. A flappy bird. A green iguana. Mutant frog. I have no idea what to do with nematode. What is a nematode? Is it like... fiery dragon, a real unicorn, cuddly lion, mantis shrimp, mantis shrimp. Mantis shrimp are really cool. Do you know about mantis shrimp? Okay, so now we have all these things that have two words. What do we have to do to deal with these things? What? Why do we have to do getLine? It has spaces. So we can use getLine, but here's the other thing we can do. We can just do this, right? We can just, read each one of these things exactly as it is. We don't need getLine in this case. We can use getLine if we want, but we don't need it because everything has exactly two words, and we know the first word is an adverb, right? Okay. Y'all are so compliant. You should be like, no. If you say something wrong, call me on it. All right. So now when we run this, let's compile it again. It seems to work. We'll run it. And now we're reading the line, but we're splitting the line into separate pieces. Each time we read one of these lines, we have not just the animal, but the adjective describing the animal. All right. So when we do this input, we can automatically split up the line into pieces and put each one into its own variable as long as the file format is such that every single thing has an adjective. Right? If something was missing its adjective, what would happen? It wouldn't stop. What would happen would be that, it would get all messed up. So if we take away, we take away blue cat, what's going to happen is it's going to be all confused. Right? Shrimp, polar, stuff like that. So as long as your file is formatted in a consistent way, you can just use CN and automatically have CN split up everything for you. Now, let me tell you what a beginner would do here that might go wrong, okay? People would try and read this as a string, as a single string using getLine, and then if you had to manipulate each part separately, you'd have to look in the string and figure out where the space is and then split it apart. It's a lot more work to do it that way. CN is your friend here, and by CN I also mean the file IO operator, angle, because it's automatically going to break things up into pieces for you. Have you all looked at the assignment, right? What does the file format for the refugee camp thing look like? It's got a single word name, right? And then it's got some numbers in a row. You can read all of the parts of that in one pass by doing something like this. So it would be like input file name, refugee count, number of taps, whatever. So you'd have all these variables lined up, and it would read them each line at once and put each thing into one variable. Yes, then you. Yes. Now, in the real world, you do have to have some assumptions about what's going on in your text file. Remember, things get very complicated, but this class is not the place for us to teach you how to deal with all these weird things. This class is for us to teach you the basics, and then once you understand it, when you're confronted with the weird things, if you think hard, you'll be able to come up with how to deal with them. Does that make sense? Yes? Nope, it doesn't. In this case, we're dealing with strings, but if we wanted to put some numbers in there, we could put ints in there too, right? How many blue cats do we have? We have 4 blue cats. If I can type, I'm not gonna put in plural for everything. 4, 6, 10 moose, 0 gray rats because we don't like those. Snakes are okay, they eat the rats. 1 flappy bird, 9 green iguanas, 100 mutant frogs, 100, a lot of test nematodes, right? They're pretty small. 0 fire dragons, 0 real unicorns. I don't know, I imagine there's a cuddly lion somewhere. 100 shrimp, and 4 polar bears. I don't know. How's that? And now what we can do is if we want, we can also add in here, we can have like an int number. And then when we input things, we just say input into number. And then adjective and animal, and this is getting a little bit long, so I'll split it up nicely. And then when we print this out, again, we do number, adjective, animal. This, I'm not sure if, oh, you, thank you. Let's make sure this compiles. I'm not entirely sure it will. I guess it was. Okay. And so now we run it. It also gets those numbers, right? And look, we've mixed types here, right? We've mixed variable types. We had a number and 2 strings. And we were able to read the numbers and 2 strings all in one line. This is exactly what you need to do for your project, to read the file, is do input this way, but have the right variables. Okay. All right. Questions? Other questions? Yeah. Uh-huh. Yeah. Some of it is what you did for the last project. Like the logic is still the same, right? Like the way you do. Oh, the other thing is I'll post my solution, which may not be the best solution, but if your solution, you weren't happy with your project one solution, you can, if you're desperate, use mine, you know. But yes, the algorithm for computing the amount of water at the camp is still the same. It's just you're going to have to do it using the file given multiple camps. Does that make sense? And then there's some other stuff too, like for camps that have excess water, they're going to be filling up water buffaloes to pass off to camps that don't have water. And so you need to compute how many water buffaloes they can fill up a day. So, yes?
Do you do calculations using the while for only like for the first line and the second line?
If you want to do just the 2 lines separately? Okay, well I'm going to show you, so the answer is that if you know that you're going to be doing just computations over the 2 lines, you don't need a while loop. You can just read each line, right? You can just copy the code over. If you want to only do something for the first 2 loops and you're using a while loop, it gets more complicated. You can keep track, you can keep a counter that keeps track of which line you're on and then do stuff with an if statement. Okay? So you can do virtually anything. I'm giving you all these small pieces and I'm showing you a few ways they fit together, right? So here's the difference, right? Like I have a 5-year-old son, he likes playing with Legos and he builds these little things. But I could say, hey, here's all the ways to give him, and then I can hand him like the Death Star Lego kit that's $400. It has like 15,000 pieces in it. And you know, he doesn't necessarily have all the tools to put that together right away, just like you don't have the tools to build Microsoft Word yet, right? But we're starting somewhere. You got to start somewhere. Does that help? So when you get to a situation like that, what you need to do is think about your algorithm and think about what you know and how to put those pieces together. Yes? Uh-huh. So say we wanted to do something here inside this loop. Like inside the loop in your project, once you input this stuff, what you're going to have to do here, and this, by the way, is called the body of the loop. The stuff inside the loop is called the body. Inside the body, each time you read one of those lines inside the body of the loop, you're going to have to make whatever calculations you're doing, which you've kind of done in project 1. And then once you've done those, you're going to have to output them before you go back to the top of the loop. Does that make sense? So inside the while loop, you're going to read everything off the line, you're going to do calculations, you're going to output something, and then you're going to go read the next line. Yes, sir. So you can just open up your editor and type one out like I did here. You can download the one that I gave you through the web page, or you can copy it over from my directory on CS Sun. And I can't remember if I put that in the directions or not, but if I didn't, email me and I'll add it. So. No. Still got to do your input checking. Okay, it's just the thing you're input checking on is no longer like what the person's typing directly, it's what they typed into the file that's wrong that you're not reading it. And if you get an error, just quit. Yes? Yep. For the purposes of, what? Yeah, but I'm being nicer to you this year. Okay? So honestly, I'm making the projects easier this semester, and I'm doing it for a reason. And the reason is that last semester, I had all the people who I knew were going to be computer science majors, and I was being mean to them to make sure that they were prepared for the major. I don't know that you're going to be a computer science major. How many of y'all want to be computer science majors? If enough of you raise your hands, I'll make the project a lot harder. So, no social pressure. No, you're still going to get the same thing. I just made the projects a little bit harder because I knew it was majors, and I wanted to make sure the majors were prepared. And I told them that the last day of class, so that's not something that they should be surprised by. Anyway. Yes?
So about this project, do you suggest that we...
Is that someone's phone? Because my rule is I get to answer it. But go ahead and answer your question.
that we use our last project and work from there, or completely start over?
I don't know. Whichever works better for you. I am lazy. When I did this, I reused much of my code from my last project. So, because I'm lazy. But if you didn't do well in your last project and you want to do better, feel free. Yes? Okay, here's the deal. When I put out the project, I made a mistake and I put out the wrong stuff. Instead of having switch, I should have put while. And so I went back and I added the while loop, but I didn't take the switch away. If we had been on a normal scale, we would have seen switch by now, but since we missed the snow day and I'm rushing all over here in Fro just teaching you random stuff with no particular order in mind so that you have what you need, we don't need switch right now. We'll get to switch soon if we don't get more snow days on Thursday. In which case, we might just cancel the whole class for the semester. So I'll give you all A's. How's that sound? Just, you have to promise never to take another computer science class. All right. Other questions? Let me just show you one more thing. Let's say, by the way, how many animals were in our file? Did you all see? How many different kinds of animals? Let's say we wanted to know how many animals were in our file. What would we do? Okay. So one thing we might do is we might go look at the data file and count ourselves, but are we very good at counting compared to the computer? No, we suck, right? We suck compared to the computer at counting things, so we can just have the computer count things. So here's what we can do, is we can say int, we can call it Noah's count of animals. And when we start, how many animals are there? 0. And what we can do is inside this loop, every time we successfully read another one, we can just say, oh, we saw another animal. And what we're going to do is we're going to increment this counter like that. Now remember the other day when I told you that plus plus happened all the time and it was super common? The reason that you didn't believe me is because you hadn't been introduced to loops yet. Counters, this plus plus is used all the time in loops. So here's what I did. I created that integer variable. This integer variable, Noah's count of animals. Down here, every time we successfully read a line, I add 1 to it. And that way, I can see what was going on. And then when we're done, what I can do is I can say, okay, cout. There were, and now I regret using a long, funny variable name, Noah's count of animals. And now when I run this, we should be able to, beyond getting just the animals that were in there, it should tell us how many there were. And here we go. There were 14 animals. There were 14 kinds of animals. How about if we wanted to add up how many actual animals there were? I'll leave that as an exercise for next class. Because essentially you have to do that in your project, right? Like every time you read a camp that has a count of refugees, you have to keep count of the total number of refugees. It's the same problem as adding up all these different animals. Have a good Wednesday. I honestly and sincerely hope that I will see you on Thursday and that we won't be snowed out. If we are snowed out, I don't know what we're going to do. We'll figure out something, okay? I might have to make you read ahead. I might have to get you to watch the videos from last semester. Oh yeah, project's still due on Thursday. I told you, this class is like, it's the steamroller, and it just goes at a constant pace, and if we fall behind, we get crushed. So, don't want to do that.